So yes, that's going to be a little difference from geometric proofs. What's the justification?
Yeah.
Now over here, we're starting with two separate fractions. We're trying to get to secant of alpha.
The fish.
You see two separate fractions. What do you want to do with those fractions? You want to combine them. You want to get a common denominator. How are you going to get a common denominator?
Multiply.
By the what? By the conjugate. Good. So, and again, we haven't even thought about any identities that go along with these things. We haven't thought about how we're going to get to secant alpha. We see two separate fractions. We're going to put those two fractions together. So your conjugate is what?
1 minus sine.
Plus cosine alpha times 1 sine alpha times 1 plus sine alpha over 1 plus sine alpha. What, use alpha? Or
Because you gotta learn us.
so here we showed, all right, we're using the conjugate and we're still trying to get to 2 secant of alpha.
Yay.
Now we know the denominator, since we use the conjugate, is going to look like what? 1 minus sine squared fish. What's your numerator? We have cosine times 1 minus sine alpha. Cosine alpha minus cosine alpha sine alpha plus, there's a
Cosine
big numerator.
alpha plus cosine alpha sine alpha.
And be careful, this is addition, so we don't have to worry about our signs as much. Take note if it is a difference. If you're finding the difference between two fractions, it's going to be minus this entire quantity. So it may be good to get in the habit of putting parentheses around your second term, just so you know if it is subtraction, you're going to subtract both terms or all three terms or however many terms in that second numerator. All right, what do we have?
Sin x cancels out.
Siraj.
Yeah, I'm just going to show you.
You knew there was video going on, so. Now, what happens in your numerator? Or what happens in your denominator? What do you got, Hannah?
You have 2 cosine alpha in the numerator.
You have 2 cosine alpha in the numerator. You have one of those cosine alpha. Here's another cosine alpha. 2 cosine alpha. What happened to your cosine sine?
Cancels out.
Oh, cancel.
Sure, we had the opposite of cosine sine alpha and the positive of cosine sine alpha, so they do reduce to 0. No more cosine sine alphas. And in your denominator, we have a 1 minus a square. So you see 1 minus a square or 1 plus a square, you should be looking to your what? Pythagorean identities. Is there an identity for 1 minus sine squared theta?
Yes.
There is. What is it? Cosine squared theta, and in this case it's alpha, whatever the angle happens to be.
Swimming upstream.
Can you cancel 1 out?
So what do we have here? Let's see, Catherine. We have 2 cosine alpha over cosine squared alpha. Can we cancel here?
Yeah.
Oh.
Sure. We don't have addition or subtraction anywhere, so I don't even need to think about is this in a numerator, denominator. It's just something divided by the same thing. Yeah, there happens to be a multiple of it, but We reduce 1 power of cosine alpha in the numerator and 1 power of cosine alpha in the denominator, and we're left with 2 over cosine alpha equals 2 secant alpha. And again, we didn't do any forethought whatsoever. We didn't think about what secant was equal to. We were just working with the left-hand side, and this is where we ended up. 2 over cosine. What's something over cosine equal to? What is it, son J? Secant? 2 secant alpha equals 2 secant alpha. Is 2 secant alpha equal to 2 secant alpha?
Pretty sure.
Yes, it is. Okay, thanks for double checking, Keyword. So we did what we wanted to.
Yeah. It works. Or the next one.
Oh, good.
That looks
Oh
great.
my god.
That looks
Yeah, the last one looks awesome. Did you already do number 3? Oh, you guys are ahead of the game? All right, third one. You have a fraction and you're trying to make it a difference.
Yeah.
Alright.
What are we going to do? Jenna, do you have a strategy you would like to give us here?
I just multiplied top and bottom by the conjugate, so you can -1.
Multiplied by the conjugate.
Yeah.
All right.
Solve for the left side.
So here's a case you have tangent, secant, cosecant, cotangent. You have 4 different trig functions you're working with. I don't know if it's in our best interest to turn them all into sine and cosine. At this point, maybe it would work out that way. But we do have this +1 thing down here, and that's probably something we want to get rid of. So let's do that by multiplying by your conjugate, which is secant x minus 1 and secant x minus 1. And we're still trying to get to this cosecant x minus cotangent x. We can think of a lot of different identities that go with cosecant and cotangent. I don't know if that's going to help us at this point. Let's get our fraction together first, or rewrite our fraction and see if that gives us any clarity. So we have tangent x secant x minus tangent x. Over, and I don't know if, wow, that was a mistake. Yep, it's gone. Over secant squared x. I don't know if that was good to multiply the tangent to the secant x minus 1. Because now we have a denominator that says secant squared x minus 1. You see something squared minus 1, you should be thinking about your PIs. And is there a PI for secant squared x minus 1? What is it? It's tangent squared. So now we have a new denominator that's tangent squared x. In your numerator, we have a tangent x in both of the terms that we're taking the difference of. Yeah, so what happened? What happened, Captain? What do you mean it all just cancels out? No.
Do you factor up 10?
At least one of them.
If you want to make sure you're not going to make any sloppy mistakes, you should factor that out.
Don't miss the shape.
So basically, if we had left it as we had in our numerator and just wrote it as the 2 terms that we were going to take the product of, would have saved us a little time, but it's not a big deal. Multiplying by tangent, dividing by 2 powers of tangent, so one of those powers cancels out. And you're left with secant x minus 1 over tangent x. All right.
Almost there.
I see a road to victory. No, I don't see sign.
Oh,
I don't.
get those puns out of here.
On your right-hand side, you have two terms that are being subtracted. On your left-hand side, you have two terms that are being subtracted, but then they're being divided. You can just leave it right there in the doorway, guys.
That's a fire
You can just leave it
hazard.
right inside the doorway, and that's good.
I'm gonna have to hurt the building sets on fire.
Can't tan be 1 over cotangent? Sure. What else? Catherine's already got something in mind. I had something else in mind.
Tangent, you could change it. Cotangent, which could be cosine over sine.
So you have the same idea as Catherine. Change tangent into 1 over cotangent. I'm seeing two terms here. Perfect. Two terms being divided by one term. So you could write this as secant x over tan x minus 1 over tan x.
Shoot. Dang.
Which is where you would have been if you decided to write that as 1 over cotangent. I'm sorry. Yeah, 1 over cotangent.
Well, 1 over 10 x.
1 over tan x is cotangent x. So we can see that we got this part and that part to equal. So we just need to make secant x tan x equal to cosecant x.
Well, tan x equals sine of cosine.
What do you got back there, Hannah?
I was saying if you change secant to 1 over cosine, and then you can change tan of x to sine of x over cosine of x, and when you divide, you're like multiplying by the reciprocal.
Kelly, can I write over here?
Yep.
Yeah? All right, so we have secant x over tan x minus 1 over tan x equals cosecant x minus cotangent x. So Hannah says change secant into 1 over cosine x, and tangent is sine over cosine. So instead of having something over sine over cosine, we could write it as times cosine over sine, multiplied by the reciprocal. We might as well do it now because it's going to make us feel like we're really close to our goal. What's 1 over tangent x? It's cotangent x, so we got that part taken care of. When we have 1 over cosine times cosine over sine, cosecant, so the cosines are eliminated. We're left with 1 over sine. And what's 1 over sine equal to? Cosecant. Cosecant x minus cotangent x equals cosecant x minus cotangent x. And we did what we wanted to. You guys can give number 4.